All right, let's do this question on torque. The 110 kg coach and a substitute player of a mass of 74 kgs sit on a uniform bench. The mass of the bench is 40 kgs. On the diagram, add arrows to show all the forces acting on the bench. Okay, let's go ahead and do that. Starting off with the coach has a downwards force due to gravity. Okay, we've also got the force of the player downwards due to gravity. What else do we have? We've got the mass of this bench, and because it's uniform, we know that the center of its mass is going to be the center of its length, which is over here. Center of mass. We've got an upwards force provided by the support force A, which I'll label SFA. We've got another upwards force over here provided by support force B. So what's allowing this plank to be in equilibrium? Okay, it's all the downward forces equaling all the upward forces. Next question, what is it asking us to do? By calculating the torques around or about support B, determine the value of the support forces at A and B. So what is this asking us? So it's asking us around support force B, okay, we need to work out how much force each support force is contributing, okay? So what is the force that this support force is contributing, and what is the upward force of support force B? What is it contributing, okay? And so we're making support force B our pivot point because it's told us to calculate the torques about support force B, so around support force B. So how do we do this? How are we going to find the force that support force A and B are providing? I'm going to start off with trying to find out support force A, okay? And so what we need to do is follow our checklist. So we picked a pivot point, that's great. What we need to do next is identify our clockwise torques. Let me get rid of that for now. We've got to find out our clockwise torques, and we've also got to find out our anti-clockwise torques. And I always love to draw a table. We need to also remember the equilibrium of this plank is maintained because the clockwise torques equal our anti-clockwise torques. And remember, torque is a turning force. All the clockwise torques will balance out with our anti-clockwise torques. So let's do this step and identify our clockwise torques. What we can see here is we've got the coach and he's got this force downwards. If we continue on and follow along with this arrow, we can see that the force, the turning force, the torque is would cause the plank to spin or turn in this direction. Is this anti-clockwise or clockwise? It is anti-clockwise, so we'll pop the coach, the torque of the coach, on this side of our table. What else have we got? Let's move on to support force A. Support force A, okay, is providing a force upwards. And if we were to continue to follow this force upwards, around the pivot point B, it would spin this whole plank in a clockwise direction, okay? So we can chuck that on our clockwise side of our table. So we've got the torque of support force A spinning this plank in a clockwise direction around pivot point B. Okay, what else do we have? We've got the center of mass. So the center of mass is another force that we have to take into account. And around pivot point B, it is going to cause the plank to turn in this direction. Okay, pretend there's no floor at the bottom, okay? And it would cause this whole plank to go in an anti-clockwise direction. So we'll add that to our anti-clockwise side of our table. So the torque of our center of mass is going to be anti-clockwise. Okay, what's something else? We have our player. So if we follow his arrow, his force arrow, okay, around pivot point B, he would cause this whole side to twist in this direction, to turn in this direction. So is he going to cause the plank to go in a clockwise direction or anti-clockwise direction? Yep, he is going to cause this plank to turn in a clockwise direction. All right, so we've identified, what we've done here is we've identified our clockwise torques and our anti-clockwise torques. What I'll do is I'm going to color code them just so that we don't get confused on what's happening. So we've got our player in purple, we have our center of mass in green, and we've got our coach, oh, that's not the coach, we've got the coach in blue, and we've got support force A in red. So you can associate them with the arrows that I've just drawn. Okay, so now that we've identified everything, we've identified our anti-clockwise torques and all of our clockwise torques, we need to flesh out these equations, okay? So we need to flesh out, or we need to write the torque force for support force A. We need to write the torque equation for the player, and so on. So the equation for torque is on your formula sheet. It's this right over here. We've got torque equals force times distance, okay? And so before we go ahead, we need to actually find the forces of everything so that we can use it in our torque equation directly. Okay, it saves us a lot of trouble. So before we flesh out these equations, let's go ahead and see if we've got all the forces of everyone on the plank and everything on the plank. Let's start off with our coach. So our coach over here weighs, his mass is 110 kgs. So what is his force? To work out force, we have to use the equation F equals m times A. And so the force provided by the coach is going to be his mass times 9.8, which is acceleration due to gravity. So the force of the coach is going to be, pop this into your calculator, 1,078 newtons. Okie dokie. All right, what else can we work out the force of? We don't know the force of support force A. That's something that we have to figure out. What about the center of mass over here? Well, we know, according to the question, that the bench weighs 40 kgs, okay? So we can work with that, 40 kgs. So all we need to do is plug it into this equation here. We've got our mass of 40 kgs times acceleration, which is 9.8. Plugging that into your calculator, you are going to get, hopefully, 392 newtons of force provided by that center of mass of the plank. What else? We don't know the force provided by support force B, but we'll work that out later. Okay, what about the player? The player has a mass of 74.0 kgs, so F equals ma. We've got the mass of 74 kgs times 9.8. The force therefore equals 725.2 newtons. Okay, so again, let me just highlight everything. We've got the force of the coach, we've got the force provided by the center of mass, and then we've got the force of the player. All right, now what we can do is we can solve all the torque equations and flesh it out. So before I go ahead and do that, let me write the symbols for everything, just so it's really clear for you, okay? So to flesh out or work out the torque equation for support force A, we are going to have to work out torque by using its force times its distance. So the force of support force A times its distance, okay, plus the force of the player times its distance from the pivot point. Okay, let's highlight everything. This is going to add up as the total clockwise torques, and all of these clockwise torques added will equal the anti-clockwise torques. So we've got the torque of the coach, and that is going to be worked out by multiplying the force of the coach, C for coach, times the distance of the coach from the pivot point, plus the force of our center of mass, times the distance of our center of mass from our pivot point B. Okay, again, let me highlight everything so it all makes sense. All right, so now that we've got our variables, all we have to do is plug in the numbers into everything, okay? So let's go ahead and do that, starting with our clockwise torque. So the force of support force A is unknown, so it's going to remain as FA. But do we know the distance of support force A from our pivot point? Let's have a look at our diagram. We've got a few distance values, okay? We've got a few distance values, and as we can see, our distance from support force A to support force B is 0.6 meters. So let's plug that into our equation. 0.6 meters is our distance of support force A to our pivot point. Okay. Now, let's substitute in our number values into our torque equation for the player. So the force of the player is something that we've just worked out previously, and that is 725.2 newtons times his distance to the support force. So as we can see, the question already provides that for us. So it's 0.420 meters. All right, so moving on, we've got our force of the coach. Do we know the force of our coach? Yes, we do. We've just worked that out over here. The force of the coach is 1078 newtons. What is the distance? What is the distance of the coach from the pivot point? Well, let's have a look-see. We've got this distance value over here to support force A, and then what is this remaining distance to support force B? Well, we can see down here that from A to B, it is 0.6 meters, okay? So I'll rewrite that up here, 0.600 meters. So if I add this value over here with this value over here, I should get the length of the coach, okay, where the coach is sitting, to support force B. So let me write that down in my equation. I've got 0.350 plus 0.600, okay, and that is that's the distance. Okay, so that's dealt with. We've fleshed that equation out nicely. Let's move on. We've got the force of the center of mass. The force of the center of mass is also been worked out previously by us, and that is why did I just rub that out? That is 392 newtons. 392 newtons times the distance away from the support force. Okay, it's not too obvious in the diagram, so we have to do a bit of thinking and maths for this. So we have our center of mass over here, as you can see. Okay, it's in the center of our plank. So the whole plank is 150 meters. So the center of mass is obviously halfway because it's in the center. So the center, from the center point to the end of the plank, if we do 1.50 divided by 2, we can find that the half length of this plank is going to be 0.75 meters, right? So we know that this length over here is 0.75. I've just drawn this line in black. Okay. So how do we figure out this length over here? We can see from B to the end of the plank is 0.450 meters, okay? And so if the total length, okay, from center of mass to the end of the plank, let me just draw this out. So we know that this is the total length. From point B to this point here, we've got 0.45 meters. So what is going to be the length from here to here? Well, all we have to do is we have to minus 0.45 from the total length of 0.75, okay? And then we'll be left with this length here. So 0.75, which is the total length of this thing, okay, minus this length over here, minus 0.45, is going to equal 0.3. So we know that from the center of mass over here to point B over here is 0.3, okay? 0.3. So we can plug that into our distance over here, 0.3, and then we've just worked out the center of mass distance from the pivot point B. So far, so good. Now what do we do? Well, let's go back to the initial question and see what we're trying to find out. So we need to try find the force provided by the support force A, okay? So have a look at the equation. We've got so many known variables and we've got this unknown force of support force A. What we can do for now is we can simplify everything so that this makes the equation a little bit more easier to follow and less clunky. So I'm going to rewrite this whole thing and simplify as I go. So we've got FA, we don't know what it is, so we leave it as FA, times 0.600, okay, plus all of this, okay, the torque of our player. So simplifying that into your calculator, what you should get is 304.584. So that is the torque value for the player. All of these clockwise torques equal our anti-clockwise torques. So let's simplify all of this over here. What you should get is 1024.1, entering that into your calculator, and that is the torque of our coach, plus the torque of our center of mass, and that is going to be simplified to 117.6 Newton meters. All right, now everything is less clunky. All you have to do now is a bit of algebra. So we need to get FA all by itself. That's the thing that we're solving for, but currently it's attached to a few things. So like an onion, we are going to focus on peeling the layers from outside in. So if FA is the center of the onion, we've got a layer over here and then a layer over here. So this is the outermost layer, okay? The player is the outermost layer, and so we're going to get rid of it. How do we get rid of plus 304.584? The opposite of that is going to be minus 304.584. So what we do is cancel it out from this side, and what we have to do now is we have to minus it from this side over here. Okay, moving on, what we get as a simplified equation is FA times 0.600 equals, I'm going to simplify this whole side, and what we should get is 837.116. Okay, so what do we do now? We need to rearrange some more. We're almost there. We need to get rid of this times 0.600. The way to get rid of that is to divide this whole side by 0.600 and divide this whole side by 0.600. Okay? And so what we get is FA equals, this is the grand finale, almost, is 1,395.193 newtons. Okay, so support force A, what is the force that it's providing? It is going to be 1,395.19 newtons. Okay, and that's how it's done. But that's not the end of the question. Why is it not the end of the question? Well, it says that we need to calculate the force provided by A and B. We've just done A, that's great, but we need to do support force B. So we could do this whole process again by making support force A the new pivot point, but I've got an easier way. So while one rule might be that clockwise torques equals anti-clockwise torques, another rule that you should know about for maintaining equilibrium is that all the upwards forces must equal the downwards forces, okay? That's another rule that you should know. So again, we're doing a table again, but a different version. And so let's identify all of our upwards forces. So if we go back to the diagram, we notice that one of the upwards forces, let me pick a different highlighter. One of the upwards forces is our support force A. Another upwards force is support force B. Are there any other upward forces? Not that I can see. So that now we can add that to our little table. So support force A plus support force B. Okay. What else do we need to do? We need to find all the downwards forces. So let's highlight them. We've got, use yellow. We've got our coach. Oh, that's not what I want. We've got our coach, and he is providing a downwards force. What else? We've got our center of mass, that is also a downwards force. And we've got our player, that is also a downwards force. So let's add that to our little table. So we've got our coach, his force, plus what else? We've got the force of our center of mass, and then we've got the force of our player. Cool. Where is this going? We need some numbers. To work out force, okay, this is something we've already done previously. We don't have to go through the effort of working force out again. Let's look at what we've got. So the force of the coach, let's start off with support force A, shall we? Okay, support force A, we just worked out was 1395.193. Okay, just worked out. Support force B, that is what we're trying to find. Okay, this is the mystery we're trying to solve. What about the force of the coach? Well, we know it's 1,078 newtons. What about the center of mass? We know that is 392 newtons. What about the player? He has got a force of 725.2 newtons. Cool. Now let's simplify this equation to make it less clunky. And so what we have here on this side, we can't simplify it further. So we're just going to leave it as it is. And then we've got this side here, which we definitely can simplify. So adding all of these values together, we get 2,195.2. Alrighty. Now what we got to do is we need to solve for support force B. How do we get it all by itself? Currently it's attached to plus 1395. So how do I get rid of it? I have to minus it from this side. So let's minus it from this side. That cancels it out. That means I have to minus it from this side. Cool. So this equation now looks like SFB, support force B, equals all of this. And if I enter that into my calculator, what I get is 800 newtons. So support force B has the value of 800 newtons. So make sure you write that nicely for the examiner, okay? So they don't have to find your answers. Make sure it's very clear. Support force A has this much of force that's providing upwards, and support force B provides this much of force upwards, okay? And they are different. They are different because we've got different masses on each side of these support forces. So to counteract the other forces, this is how much support force A needs to provide, and this is how much support force B needs to provide to counteract all the downward forces so that this plank stays in equilibrium. All right? So that's the end of that question. It was a huge one, but hopefully it makes sense. If it doesn't, please let me know.